Okay, so in this video we're going to be talking about solving equations with logarithms. Now I have done a similar one before, but these ones are exponential equations and we're going to be using logarithms to help us. I've written just a little blur at the top that if you want to write it down you can. So the method we're using is a thing called taking logs on both sides, and then I've just sort of written this bit of how it works. So if you have f of x and g of x, these are just two different functions. So for example, for this one, it would be the 3 to the power of x and the g of x would be 20. They don't always need to have x's on both sides. But if we take logs of both sides, making sure that the base numbers, so the little a's, are the same, they are also equal. Okay, so we can use this rule where we take logs of both sides to be able to then solve the equations. Now, I've got two different methods, so method 1, method 2. Now, method 1 is the method that I learnt when I was at school. It's your decision which one you use. There are, for example 3, you do have to use example 1 to do it, and I'll explain why at the time. But for these ones and for EG2, when you've only got one thing with a power, it doesn't actually matter which method you use, you can just pick which one is easier for you. Okay, so first example, solve the following equations given your answers to 3 decimal places. Now I am going to be using 2 calculators, so I'm going to start off with my normal one, so GCSE, and then I'll show you how to do it on the A-level one. But to be honest, it doesn't matter which calculator you've got. So method 1. So we start off with this. We've got 3x to the power of 3 to the power of x equals 20. Now we're going to have to use a calculator at the end because it does say 3 decimal places. So the first method is that we just take logarithms of both sides. Okay, so it would be log of 3 to the x equals log of 20. Now it doesn't matter what base you use. Okay, so when I've just written log like this, I've assumed that it has a log of power 10. Now if you're using your normal calculator from GCSE, you have this button here which is just log, and it does it straight away for you. Okay, oh, cos. There you go, log. Okay, and that is log of base 10. Okay, now on your scientific one, your A-level one, you don't have that option. Okay, you've only got the proper one with the base, so you can just write base 10. Okay, so once we've done that, using our logarithm rules, one of the rules is that the power can come to the front. So this is the same as x log 3 equals log of 20. Now I'm not going to keep writing base 10, okay, just so you know that it is base 10. That's what I've written on the first row, but you don't need to write it every time. Okay, now these two are multiplied together, the x and the log of 3. So I'm going to divide both sides by log of 3. So we then have that x is equal to log 20 divided by log of 3. Okay, so using calculator, log 20 divided by log 20 divided by log 3. And you get 2.7.2. So how many decimal places? 3. So 2.727. Okay, to 3 decimal places. Now if you're doing it on here, okay, you'd do the log button, but you've obviously got to put the base in, so log 10 of 20 divided by log 10 of 3. Okay, but you still get the same answer. Okay, so that's method 1. Method 2, you do still take logs of both sides. Okay, but this time you're going to take logs of the number that you have as, so we call this the base number. Okay, so the big number and then you've got the power, that's the base. So we're going to do log to the power of, or the base of 5. Okay, equals log base 5 of 61. Okay, the next bit is the same, so I'm going to put the power to the front. Okay, I'm just going to leave it with a bracket around it just because there are two terms in the power. Okay, equals log 561. Now, one of the rules that we did when we were doing rules of logarithms, if the base is the same as the big number there, this is just the same as equal to 1. So actually, we've only got this 4x minus 1, and then the rest will stay the same, log 5 of 61. Okay, then we're going to solve it just how you would do it at GCSE to work out what x is. So plus 1 onto both sides. So 4x equals log 561 plus 1. Okay, and then divide by 4. So we've got x equals log base 5, 61 plus 1, all divided by 4. Okay. So I'm going to use fraction 1. So log base 5, 61 plus 1 divided by 4 equals 0.88. This is to 3, so it would be 0.889. Okay. Okay, same with this one. So this one's quite nice. You've got the button there as well. So fraction base 5, 61 plus 1, all divided by 4. And again, you get the same answer. Okay, so either method will work. So I could have used method 1 on this. Okay, and you get the same answer. So they're the basics. So now I'm going to move a little bit harder. So EG2, solve the equation of 5 to the power of 2x minus 12 bracket 5 to the power of x plus 20 is equal to 0. Given your answer to 3 significant figures. So when you have ones like this, you've got to identify straight away that this is actually a quadratic. Okay. Now the reason how you can tell is because if we look at this 5 to the power of 2x, okay, we can actually write that as 5 to the x squared, okay, because when you have brackets like that and powers of indices, you then multiply them. So 2 times the x will give you the 2x. So there are different ways of doing it. If you can just factorise it straight away, fantastic. If you can't, what you can do is replace, actually I'm going to call it y, just so there's not too many x's. So I can change the 5 to the power of x to be the letter y. So for the first part, that's going to be y squared, okay, using this sort of method. Then we've got minus 12, okay, and then we've got 5 to the power of x, which we've said is y. And then we've got the plus 20. And we make that equal to 0. Then we factorise it, okay. So 2 numbers that multiply to make positive 20 but add to make minus 12. So that's going to be minus 2 and y is minus 10. Okay, so that solves that y is 2 and y is 10. Okay, but obviously y isn't y, okay, y is actually this. So the actual 2 equations we've got is 5 to the x equals 2. And 5 to the x equals 10. Okay, I'm going to draw an arrow to go over here. Okay, so I'm going to call them label 1 and 2. When you do it, you don't need to call them 1 and 2, but it's just so that we can go through it. Okay, so I'm going to use method 1 for the first one, and then I'll use method 2 for the second. So method 1, so we've got 5 to the x equals 2. So we're going to take logs of both sides. So log 5 to the x equals log 2. That's the same as x log to the 5 equals log to the 2. Because of the rules, the power can come to the front. So x is log 2 divided by log 5. Okay, so using a calculator. Remember, it's just base 10. So 2 divided by log 5. and we get that. So 3 sig figs, 0.431. 0.431. Cool. And then for number 2, so this is method 2. So we've got 5 to the x equals 10. So take logs, but have the base number be in the big power, the big number with the power. 5 to the x equals log 5 to the 10. So that's the same as x log to the 5. 5 equals log 5 to the 10. And that's equal to just 1. So x is equal to just log 5, 10. So log 5, 10. So that would be 1.43. 0.43. So that's my first answer. And that's my second one. Okay. Okay, so for the last one. So find the solution to the equation 3 to the x equals 2 to the x plus 1, giving your answer to 4 decimal places. Now the reason why you've got to use method 1 for this question is because you've got 2 things that have powers and they are not the same number. So if I just scroll back to the top. So I wrote here that when f of x is equal to g of x, when you take logs but they have to be the same base, that's what the little a's are about, they're equal. Now if we use method 1, I said that the base there has to be the same as the big number here, but that's not going to work when we do this question, because for this one it would have a base of 3 and that one will have a base of 2, which means that actually they won't be equivalent to each other. Okay, so you have to use method 1. Always method 1. Okay, because they are different base numbers. So first thing we're going to do, we're going to take logs of both sides. So log of 3 to the x equals log of 2 to the x plus 1. Remember, these are both base 10. Okay, so let's bring the powers to the front. So x log of 3 equals, put this in brackets just because there are 2 terms. You've got the x and the plus 1. Log of 2. Okay, I'm going to expand out. So x log 3 equals, you're going to have x log 2 plus log 2, because x times that gives you this and 1 times log just gives you that. Okay, we want the x's to be on the same side, so I'm going to subtract that from both sides. Log 2 x log 2, run out of space, move up a little bit. So we've got x log 3, that was originally there, subtract x log 2 equals log 2. Okay, they've both got an x in common, so we can factorise that x out. Okay, and we would have that. And then we divide by the bracket. Okay, so let's bring this over here, just so I've got a bit more space. So you're going to have the x is equal to the log 2 that was originally there, divided by log 3 minus log 2. Fraction log 2 divided by log 3 minus log 2. Oh, I keep forgetting the brackets. Log 2 bracket, there we go. Log 3 bracket minus log 2 bracket. And we get that. How many decimal places? 4. So it's going to be 1.7095. So that's my final answer. Okay.